Electrical utility companies are generally required to follow the National Electrical Code, referred to as the NEC, in their electrical installations and work. The NEC serves as a comprehensive set of safety standards recognized nationally for the installation and maintenance of electrical wiring and equipment. Most states and municipalities across the United States have adopted it, and it also forms the basis for numerous other electrical codes worldwide. The NEC addresses a broad spectrum of electrical topics, including wiring methods, equipment installation practices, overcurrent protection measures, grounding and bonding techniques, safety devices, and guidelines for special installations. Utility companies are mandated to adhere to the NEC to guarantee the safety and code compliance of their installations and work. This adherence is crucial in protecting the public from potential electrical hazards, ensuring that electrical systems are appropriately designed, correctly installed, and properly maintained. In addition to the NEC, electrical utility companies might also be obligated to comply with other codes and standards, such as those established by the Occupational Safety and Health Administration, known as OSHA, and the American National Standards Institute, or ANSI. These additional codes and standards are designed to further ensure that electrical work is conducted safely and aligns with industry best practices. Let's delve deeper into the specific areas covered by the NEC and their relevance to utility companies. Firstly, wiring methods are detailed extensively in the NEC, covering approved types of conductors, their insulation, and how they should be installed in various environments. For utility companies, this is critical in ensuring that overhead and underground power lines are installed safely and can withstand environmental factors such as temperature variations, moisture, and physical stress. Secondly, equipment installation standards in the NEC provide guidelines on how to properly install electrical equipment, such as transformers, switchgear, and generators. These guidelines help prevent overheating, short circuits, and other equipment failures that could lead to power outages or safety hazards. Thirdly, overcurrent protection is a significant focus of the NEC, addressing the use of circuit breakers and fuses to protect electrical systems from overloads and short circuits. Utility companies must implement robust overcurrent protection schemes to prevent damage to their equipment and to protect the public from electrical fires. Fourthly, grounding and bonding are essential for electrical safety, and the NEC provides detailed requirements for these practices. Proper grounding and bonding help to ensure that electrical faults are safely conducted to ground, minimizing the risk of electric shock. Utility companies must adhere to these requirements to protect their workers and the public. Fifthly, safety devices, such as ground fault circuit interrupters, known as GFCIs, and arc fault circuit interrupters, known as FCIs, are covered in the NEC. While these devices are more commonly used in residential and commercial settings, utility companies may also need to use them in certain applications to enhance safety. Sixthly, special installations, such as those in hazardous locations or healthcare facilities, have specific requirements in the NEC. Utility companies may encounter these types of installations when providing power to industrial facilities or hospitals, and they must be aware of and comply with the relevant requirements. Now let's consider the role of OSHA and ANSI in regulating electrical safety for utility companies. OSHA is a federal agency responsible for ensuring safe and healthful working conditions for employees. OSHA has specific regulations related to electrical safety, including requirements for lockout/tagout procedures, personal protective equipment, and safe work practices. Utility companies must comply with OSHA regulations to protect their employees from electrical hazards. ANSI is a private, non-profit organization that develops voluntary consensus standards for a wide range of products, processes, and services. ANSI standards related to electrical safety cover topics such as electrical equipment design, testing, and installation. While compliance with ANSI standards is generally voluntary, many of these standards are incorporated into regulations or are considered industry best practices. Utility companies may choose to follow ANSI standards to demonstrate their commitment to safety and quality. To summarize, electrical utility companies are required to follow the NEC to ensure the safety and code compliance of their electrical installations and work. They may also be required to comply with other codes and standards, such as those set by OSHA and ANSI. These codes and standards help to protect the public from electrical hazards and ensure that electrical systems are properly designed, installed, and maintained. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important for electrical utility companies to stay up to date with the latest version of the NEC and to ensure that their employees are properly trained in the code requirements. One area of significant importance within the NEC is Article 250, which covers grounding and bonding. Effective grounding and bonding are essential for providing a low impedance path for fault currents, which helps to quickly trip over current protection devices and minimize the risk of electrical shock. Utility companies must adhere to the requirements in Article 250 to ensure that their grounding systems are properly designed and installed. Another critical aspect of the NEC for utility companies is Article 310, which deals with conductors for general wiring. This article specifies the allowable ampacities of different types of conductors based on their size, insulation, and installation conditions. Utility companies must carefully select conductors with adequate ampacity to prevent overheating and ensure the reliable delivery of power. The NEC also addresses the installation of electrical equipment in hazardous locations, such as areas where flammable gases or vapors may be present. Article 500 and subsequent articles provide detailed requirements for equipment and wiring in these locations to minimize the risk of explosions or fires. Utility companies must comply with these requirements when providing power to industrial facilities or other locations with hazardous atmospheres. In addition to the technical requirements of the NEC, it is also important for utility companies to have robust safety programs in place. These programs should include regular training for employees on electrical safety practices, as well as procedures for identifying and mitigating electrical hazards. Utility companies should also conduct regular audits of their electrical systems to ensure that they are in compliance with the NEC and other applicable codes and standards. The enforcement of the NEC varies depending on the jurisdiction. In some areas, the NEC is adopted directly by the state or local government and is enforced by electrical inspectors. In other areas, the NEC is used as a guideline, but the local jurisdiction may have its own electrical code that is based on the NEC. Utility companies must be aware of the specific requirements in their service areas and ensure that their installations comply with all applicable codes. Furthermore, the NEC includes specific tables that are used to determine the proper sizing and installation of electrical components. For example, Table 310.16 provides ampacity ratings for various conductors based on their insulation type and ambient temperature. Utility companies rely heavily on these tables to ensure that their electrical systems are designed and installed safely and efficiently. The NEC also addresses the proper use of overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect electrical circuits from overloads and short circuits, which can cause fires or other hazards. Article 240 of the NEC provides detailed requirements for the selection and installation of overcurrent protection devices. Utility companies must ensure that their overcurrent protection devices are properly sized and installed to provide adequate protection for their electrical systems. The NEC also covers the requirements for grounding and bonding of electrical systems. Grounding is the process of connecting electrical equipment to the earth, which helps to protect against electrical shock. Bonding is the process of connecting different metal parts of an electrical system together, which helps to create a low impedance path for fault currents. Article 250 of the NEC provides detailed requirements for grounding and bonding. Utility companies must ensure that their grounding and bonding systems are properly designed and installed to provide adequate protection against electrical shock and other hazards. In addition to the NEC, utility companies may also be subject to other regulations and standards, such as those promulgated by the Federal Energy Regulatory Commission, or FERC, and state public utility commissions. These regulations may address issues such as grid reliability, cybersecurity, and environmental protection. Utility companies must comply with all applicable regulations to ensure the safe and reliable delivery of electricity to their customers. The NEC also contains requirements for surge protection devices, known as SPD. These devices are designed to protect electrical equipment from voltage surges which can be caused by lightning strikes or other events. Article 280 of the NEC provides requirements for the installation of SPD. Utility companies may use SPD to protect their sensitive electronic equipment from damage due to voltage surges. The NEC also addresses the requirements for electrical installations in healthcare facilities. These facilities have unique electrical needs, as they rely on electrical equipment to provide critical care to patients. Article 517 of the NEC provides detailed requirements for electrical systems in healthcare facilities. Utility companies must comply with these requirements when providing power to hospitals, clinics, and other healthcare facilities. The NEC also includes requirements for renewable energy systems such as solar photovoltaic, known as PV, systems and wind turbines. As renewable energy becomes more prevalent, utility companies are increasingly connecting these systems to the grid. Article 690 of the NEC provides requirements for the installation of solar PV systems, and Article 694 provides requirements for wind turbines. Utility companies must comply with these requirements when connecting renewable energy systems to their grid. The NEC also includes requirements for energy storage systems such as batteries. Energy storage systems are becoming more common as a way to improve grid reliability and integrate renewable energy sources. Article 706 of the NEC provides requirements for the installation of energy storage systems. Utility companies must comply with these requirements when installing energy storage systems on their grid. The NEC also addresses the issue of arc flash hazards. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flashes can cause severe burns, injuries, and even death. Article 110.16 of the NEC requires that electrical equipment be marked with warning labels to alert workers to the potential for arc flash hazards. Utility companies must conduct arc flash hazard assessments and implement measures to protect their workers from these hazards. The NEC is a complex and comprehensive document, and it is essential for electrical utility companies to have a thorough understanding of its requirements. Utility companies should provide regular training to their employees on the NEC and other applicable codes and standards. They should also conduct regular audits of their electrical systems to ensure that they are in compliance with all applicable requirements. By following the NEC and other applicable codes and standards, electrical utility companies can help to ensure the safety of their workers, the public, and the electrical grid. Furthermore, the NEC addresses specific requirements for communications systems. With the increasing reliance on digital communication for grid management and control, utility companies must ensure their communication infrastructure adheres to NEC standards to maintain reliable and safe operation. Article 800 of the NEC provides guidelines for the installation and protection of communication circuits and equipment. This includes considerations for grounding, bonding, and separation from power conductors to prevent interference and ensure the integrity of communication signals. The NEC also provides guidance on the selection and installation of cables and wiring methods used in communication systems, taking into account environmental conditions and potential hazards. Another important area covered by the NEC is the proper use of personal protective equipment, known as PPE, for electrical workers. PPE includes items such as insulated gloves, sleeves, and footwear, as well as arc-rated clothing. The NEC requires that electrical workers use appropriate PPE when working on or near energized electrical equipment. Utility companies must provide their employees with the necessary PPE and ensure that they are properly trained on how to use it. The NEC also addresses the issue of lockout/tagout procedures. Lockout/tagout is a safety procedure that is used to prevent accidental energization of electrical equipment during maintenance or repair work. The NEC requires that utility companies have a written lockout/tagout program and that their employees are properly trained on the procedures. Furthermore, the NEC addresses requirements for electrical testing and maintenance. Regular testing and maintenance are essential for ensuring the safe and reliable operation of electrical systems. The NEC provides guidelines for the types of tests that should be performed on electrical equipment, as well as the frequency of these tests. Utility companies should have a comprehensive testing and maintenance program in place to ensure that their electrical systems are properly maintained. The NEC also includes requirements for electrical safety training. Electrical safety training is essential for ensuring that workers are aware of the hazards associated with electricity and how to work safely around electrical equipment. The NEC requires that utility companies provide their employees with regular electrical safety training. The training should cover topics such as the hazards of electricity, safe work practices, and the proper use of PPE. The NEC also addresses the importance of documentation and record keeping. Proper documentation and record keeping are essential for ensuring that electrical systems are properly maintained and that any problems are quickly identified and corrected. The NEC requires that utility companies maintain records of their electrical installations, testing, and maintenance. These records should be kept up to date and readily available for review. In conclusion, compliance with the NEC is not just a legal requirement for electrical utility companies, but also a critical factor in ensuring the safety of their employees, the public, and the reliable operation of the electrical grid. By adhering to the NEC and implementing robust safety programs, utility companies can minimize the risk of electrical hazards and provide safe and reliable power to their customers. The NEC is not a static document. It is continuously updated and revised to reflect changes in technology and best practices. It is therefore essential for utility companies to stay informed about the latest changes to the NEC and to ensure that their employees are properly trained on the new requirements. The NEC is a cornerstone of electrical safety, and its importance cannot be overstated.